Welcome to this tutorial on solving quadratic equations using the method of factoring. Whether you're a student preparing for exams or just looking to brush up on your math skills, this guide is perfect for you. We will break down the steps and ensure that you understand when and how to use this method. Before we begin, it is important to mention that even though factoring is efficient and quick to apply, it works well for simpler equations. Sometimes factoring is not possible, in which case we may have to use the quadratic formula, a universal tool that works for any quadratic equation. To ensure that this tutorial is comprehensive, we briefly discuss how to solve linear equations. A linear equation is an equation of the form ax plus b equals 0. Solving this equation is fairly straightforward. First, move b across the equal sign, changing its sign, and then divide by a to find the value of x. An example is 2x plus 6 equals 0. To solve for x, we first take 6 across the equal sign, and since 6 is positive on the left side of the equal sign, it becomes negative on this side. Next, we divide by 2 to get the value of x to be negative 3. Now, let's move on to quadratic equations. A quadratic equation is a polynomial equation in the form ax squared plus bx plus c equals 0, where a, b, and c are numbers, and a is not equal to 0. The expression b squared minus 4ac is called the discriminant, which is very important as it indicates whether the equation has real solutions. If the discriminant is a positive number, the equation will have two solutions. If the discriminant is equal to 0, the equation will have just one solution, which is negative b over 2a. If the discriminant is a negative number, the equation has no real solutions. Solving quadratic equations by factoring involves rewriting the equation as a product of two linear functions set to 0. That is, we write ax squared plus bx plus c in the form dx plus e times fx plus g. Since the two expressions are identical, other than solving the original equation, we solve dx plus e times fx plus g equals 0. To do so, we apply the zero product property, which states that if the product of two factors is 0, at least one of the factors must be 0. This means that dx plus e must equal 0, or fx plus g equals 0. Then, we solve these two linear equations to find the values of x. To use factoring, it is important to check if indeed the quadratic expression can be factored. To do so, we use the factorability condition, which states that if the discriminant is a perfect square, the quadratic expression can be factored. Remember that a perfect square is a number that can be written as the square of an integer. Examples are 0, which is 0 squared, 1, which is 1 squared, 4, which is 2 squared, and 49, which is 7 squared. The main challenge of using factoring is writing the equation in factored form. One technique is to find two numbers whose sum is b and whose product is a times c. Then replace bx with the sum of these two numbers, each multiplied by x, and then factorize. Here is an example. Consider solving x squared plus 5x plus 6 equals 0. Here, a is 1, b is 5, and c is 6. First, we check if this equation can be solved by factoring. We calculate the discriminant, given by b squared minus 4ac, which is 5 squared minus 4 times 1 times 6, which equals 1. Since 1 is a perfect square, we can use factoring. To factor, we find two numbers whose sum is b, that is 5, and whose product is a times c, which is 6. Those numbers are 2 and 3. Next, we replace 5x in the equation by 2x plus 3x to get x squared plus 2x plus 3x plus 6 equals 0. Then, we take the first two terms together and the last two also together. That is x squared plus 2x plus 3x plus 6. The first expression has x in common, so we pull it out to get x times x plus 2. The second term has 3 in common, so we factor it out to get 3 times x plus 2. Both expressions now share x plus 2, so we factor this out, leaving x in the first term and 3 in the second. Successfully, we have factorized x squared plus 5x plus 6 into x plus 2 times x plus 3. Therefore, solving x squared plus 5x plus 6 equals 0 implies that we solve x plus 2 equals 0 to get x equals negative 2, and x plus 3 equals 0 to get x equals negative 3. Hence, the solution to the equation is x equals negative 2 and x equals negative 3. Here is another example. Consider solving 2x squared minus x minus 6 equals 0. We have a equals 2, b equals negative 1, and c equals negative 6. The discriminant is given by negative 1 squared minus 4 times 2 times negative 6, which is 1 plus 48. The result is 49, which is a perfect square. Therefore, we can use factoring. Now, we look for two numbers whose sum is negative 1 and whose product is 2 times negative 6, which is negative 12. These are negative 4 and 3. Next, we replace negative x in the equation with minus 4x plus 3x to get 2x squared minus 4x plus 3x minus 6 equals 0. The first two terms have 2x in common, so we factor it out to get 2x times x minus 2. Similarly, we factor 3 out for the last two terms to get 3 times x minus 2 and set everything to 0. The two terms have x minus 2 in common, so we factor it out to get x minus 2 times 2x plus 3 equal to 0. Using the zero product property, we have x minus 2 equals 0, from which we get x equals 2, and 2x plus 3 equals 0, which gives us x equals negative 3 over 2. Let's consider another example. X squared minus 9 equals 0. Observe that the x term is missing, which we can introduce by inserting 0x to get x squared plus 0x minus 9 equals 0. Then a is 1, b is 0, and c is negative 9. The discriminant is 0 squared minus 4 times 1 times negative 9, which equals 36, a perfect square. Therefore, we can apply factoring. As an exercise, use the technique discussed above and see if you arrive at the same solution we will obtain below. Now, if the x term is missing, it is easier to factor the equation using the difference of squares formula, which states that a squared minus b squared equals a plus b times a minus b. Since 9 is the same as 3 squared, we rewrite x squared minus 9 equals 0 as x squared minus 3 squared equals 0. Comparing this to the difference of two squares formula, we match a with x and b with 3. Then the equation becomes x minus 3 times x plus 3 equals 0. Solving the two equations, we have x equals 3 and x equals negative 3. Now, on to our first test problem. Solve x squared minus 2x minus 8 equals 0. The solution is x equals 4 and x equals negative 2. For our second problem, solve 6x squared plus x minus 1 equals 0. The solution is x equals 1 over 4 and x equals negative 1 over 2. And lastly, solve x squared minus 225 equals 0. The solution is x equals 15 and x equals negative 15. I hope you enjoyed this tutorial. Please leave comments and suggestions for improvement, and don't forget to like and subscribe for more content.